Looks like your son is on. Josh Hubbell. So who do we have on right now? James the astrophotographer, Michael Whitaker, Andrea Villarreal. Hello, happy Friday. Cesar Brolo, happy Friday to everybody. The Richard Grace, the Astro Beard. Michael Whitaker saying, "Is it Friday?" Question mark.
Hmm.
And
Josh is
Hubbell
on.
saying, "Hey, Dad."
Hey, how's it going?
Yeah,
Is,
um,
is
it
he?
was
I
fun.
don't know if he. I guess he's working from home today.
Yeah. Look, Davey says it's Friday.
Yeah.
Louise Helmers, happy
Can they?
Friday.
Can they hear us now?
Huh?
Can they
Yeah.
hear us? Okay.
Oh, they can hear us. Our mics are hot
Okay.
all the
Hey,
time.
Josh.
Hmm. Bergman liked the star party last night. That's all.
Oh,
That's
good.
great. Pekka says hello from Stockholm, Sweden. I like it when people say where they're from. It's awesome. Marco Polo says hello. Michael Wiesner, not to ruin everybody's Friday, but there's a Monday in your future. Thanks a lot, Mike.
Hopefully, there's thousands of Mondays in our future.
Yeah, that's right. He just said one, just one Monday. So that's it. You got one Monday, it's done.
And then you're done, and you don't have to work anymore. Is that what that is?
And maybe you don't have to do anything anymore, which, I don't know. Stefan Del Pra, hello, Earthlings. That's right. We are Earthlings. We're not only Earthlings anymore, though. We are a spacefaring species now. We have people living in space 24/7. So there you go.
Or solar rings?
Yeah,
I don't
that's
know if
right.
that's a word.
Solar systemlings.
So solar system rings, solar rings.
Solar rings. That's right. What is the handshake for a solar ring? I don't know. It's where two fists like orbit each other or something.
I guess.
Pekka says, "Gosh, is it Friday today? Every day seems to be kind of the same these days. I'm inside 24/7." Well, we're glad you get to spend some of that with us, Pekka. Um, Book David says, "We can hear you. We know you can." That's the reason why we talk. Wayne Porter says, "Lost in space." Um, Jeff Wise says hello from Northern California. Uh, Stefan says it's 9 a.m. there. Uh, Jeff Wise says, "Great show last night. I learned a lot." Clear light 58. Still cloudy here in the north of Boston. It's snowing outside here in Arkansas. So um, Louise Helmer says, "We hear you loud and clear." That's great. Uh, Really like the way they projected the images with the Oklahoma group. I did too. Oh, those great big images of the moon and stuff like that is cool. Michael says there's snow here in the UK. Clear Light says, "Hope everybody there is feeling better." I would say that that's true. I was talking to Kent Martz today, and he's feeling better every day, so that's good. Harold says, "We are made of stardust." That's right. And soon we'll be Martians. Milky Waylians. I like that. We're Milky Waylians, not solar systemlings.
Milky Waylians.
That's,
That's pretty cool.
that's right. Solar Anians.
That doesn't sound-
Solar Tights, Solar Anians. I like Solar Anians and Milky Waynians.
Milky Waylians, yeah.
Yeah. It's like living in the movie Groundhog Day. Um, COVID is terrible just now here in Sweden. I'm so sorry to hear that, Pekka. Yeah. Cloudy here. We all need to stop buying equipment for a few weeks. That's Stefan. Um, Cloudy and crappy as usual in Cleveland. It's from James the astrophotographer. Harold Locke says it's 87 in North San Diego County. Well, at least it's clear somewhere.
Okay, got it.
Alright. Okay, we're doing it.
Pretty much anything that you can observe on the land and coast, and sometimes even in the ocean, NISAR will have an application. Very exciting mission, generating an enormous amount of data that will keep the science community and the applications community busy for a long time.
NISAR is a partnership mission between NASA and ISRO, the Indian Space Research Organization. It's a collaborative project.
And we'll be collecting data for all around the whole Earth for all of the land masses.
Looking at volcanoes, earthquakes, landslides, other natural hazards that occur in the crust of the Earth.
A movement of sea ice, movement of glaciers, how much forest land is growing or being reduced.
Because it can image at night and through clouds, it can allow us to see through storms.
It's really going to allow us to see things changing in areas where we can't with other satellites.
The NISAR is going to open our eyes to the potential of this technique for seeing the ground in places that otherwise has been obscured.
So every 12 days we will map the land masses, and then we can take those mappings and we can compare them. We can do what we call interferometry,
where we can take an image acquired on one day and combine it with an image acquired 12 days later from that same vantage point, looking at the same point on the ground. And when we do that, we can see the motion of the ground down to a fraction of the radar wavelength, which in this case is on the order of a few millimeters.
NISAR has two radars on it, two synthetic aperture radars. One is an L band and the other is an S band.
So it's kind of the Tesla or the Maserati of radars, whichever you think is cooler, I guess.
This here is the radar payload. That is the spacecraft bus. Large 12-meter reflector, common antenna system for both L band and S band to send out the RF signal and capture the return signal.
Good morning, Dr. Paul.
Antanu, how are you today?
Yeah, I'm fine.
The pandemic is something that we were not counting on when we developed this project.
The NISAR project was actually pretty well versed with this remote operations because of that Indian engagement.
There was a little bit of WebEx fatigue, but I think we're learning how to do it better now.
But yeah, we're all in great spirits, and we will take a little hit to the schedule, but we've been waiting a long time for this mission, and we want to do it right. We want the hardware to work, and we want the science to be done.
One of the best things we can do to increase diversity in the sciences is to make it easier for people to enter the sciences.
The data is going to be freely available to everybody. We aren't going to have to pay for it like we do with some satellites.
So making the data free, having it easy to download to your own machine, all of that stuff is critical if we want to remove those barriers to entry to the field.
I'm looking forward to the sense of discovery that I think we're going to have when NISAR data start coming down.
Earth science is incredibly important to understand what's going on in the name of what our children and grandchildren are going to have to face in the future. And all the information we collect now is only going to help them understand that better and hopefully make their lives better.
Digital electronic subsystem, cognizant.
There goes my son.
You know, the radar will.
I can't recall. There we go.
That's our real life here in 2020.
I like that, launching no earlier than 2022. Well, hello everybody. It's Scott Roberts and Jerry Hubbell here with the OpenGOTO Community Live. We had a great event last night with the Night Sky Network. It was the 28th Global Star Party. It was a lot of fun. Vivian White pulled out all the stops and got in some of the, really amazing outreach people. We learned a lot about electronically assisted astronomy, different creative ways to do educational outreach in astronomy, and stuff that can be done during this, during this pandemic. So I think it's made astronomers, especially educational outreach astronomers, more creative overall. And that creativity is just something that is brought to astronomy both on the professional side and the amateur side. It's how we figure out, you know, how we figure out our place in the universe and the dynamics that go on in the universe. Of course, you have to have the science. You need to have tools that can help you prove out theories or ideas, you know, but the same kind of process goes on whether you're amateur or professional, whether you're just educating, you know, neighbors in your backyard, or you're leading big outreach programs, or you're involved in research, or you've made some discoveries, you know, so we're all kind of connected in this, and that's what makes, gosh, that's what makes the community of astronomers so vibrant and interesting. And you know, I've said it, you hear other people say it, but we are living in this golden age of astronomy, and there's no better time to be involved in it. So for all of you that are watching, we really appreciate you tuning in, and we thank you for watching the programs that we put out. Tonight we will have the Astronomical League's second live program. This is being conducted by the secretary of the Astronomical League, a former two-term president, Terry Mann. And Terry's been on every one of our shows almost all week long, and so that's been really cool to have her on and to help us promote astronomy and the education of astronomy as these people do. The show will start at an hour earlier than our normal Global Star Party. The Astronomy League Live program is a separate program altogether. We're honored to be the ones that produce that and to distribute that. But you know, it's you know, it's a program that they'll do regularly, and we have it down on our schedule of all their planned events throughout the rest of the year. If you go to explorescientific.com/live, you'll see that calendar. Plus, you're going to start to see some other things coming up, including the Winter Star Party. Okay, I'm sure all of you have heard about the Winter Star Party. Jerry, have you been to the Winter Star Party before?
Yeah, I went in 2014.
You went with us, right?
Yeah.
Yeah, that's cool. So we have, I've been to so many of them. Just kind of when I remember back, you know, the people, the faces, the experiences and stuff like that of being down in that very special place down in the Florida Keys. You know, it just kind of all blends together, but in some ways, but in other ways, it's just like I have like these little vignettes of memories. A fantastic place to do astronomy, especially high power astronomy, because the seeing conditions there can be so good. The stability of the air can often get you into arc-second or even sub-arc-second seeing conditions. And that lets you really push the magnification way up on your telescopes. More than once, I've looked through telescopes on the field at Winter Star Party where we were observing well over 100 power per inch and still seeing razor sharp images of Jupiter and Saturn and, you know, the planets out there. So it's really cool. Lots of astrophotographers are typically there. Winter Star Party also has gotten a world-class lineup of speakers. And so, but this year, because of the pandemic, they decided to take it virtual. They asked if we would produce that virtual event for them, and we are. So starting February 8th, going on, I think, until the 14th. It's several nights in a row.
That's quite a few nights.
Yeah. So you'll see it on the calendar for the login times and everything. But you're going to want to watch this. This is going to be cool. They're going to have some historical lectures by like the founder, Tippy Dioria, and many others will be on, including some new speakers that will be participating. I hope that they have some live imaging through telescopes and stuff. It's going to be awesome. So again, that starts February 8th, and so that's coming up pretty quick. And what else do I have to say? We have, well, the show for the Astronomical League Live 2 starts at 6 p.m. Central here, 7 p.m. Eastern, so it's coming up very quickly.
Yeah.
We're going to have a relatively short show today, so, but I'll turn it over to Jerry.
So yeah, so let me just, I'm going to share my screen and I'm going to show a couple things. So my topic today, I'm just going to do an overview of ASCOM and the ASCOM standards that are in place to connect telescopes to computers and what it's all about. There's other similar programs that we'll cover in the future, such as Indy, which is that's an open source platform to connect telescopes to computers with the Linux operating system and also Mac OS. And then there's another feature that we'll get into with ASCOM called Alpaca, which is a cross-platform connectivity tool also. But I'm gonna quickly share my screen. And I wanted to first share that website that Scott was talking about, the live Explore Alliance Live. This is where you'll see all the events, the event calendar. And you can see here, there's still a lot of stuff. We got stuff scheduled all over.
The Astronomical League went ahead and gave me their whole year.
Yeah,
so
it looks like
pretty cool.
Yeah.
Including the Astronomical League conference. So Alcon is going to be conducted. We were once and again asked to broadcast that, so we will. So I'm excited about that.
Cool. So that's the whole calendar, and you can get to our other programs here also that we have, our weekly programs.
Mm-hmm.
That's on the live. So let's go over to the ASCOM standards website. And like I said, ASCOM is an initiative to be able to provide a common set of connectivity standards for astronomical equipment to connect to your computer. It's very similar to, well, it's based on the Windows COM architecture, which is a common object model. So just to give you a feel for what it's all about, just for example, back in the 80s, before Windows, you had DOS, and you had programs like word processor programs like what was it? WordStar. You heard of that old program? Mm-hmm. But there's different word processor programs, let's say, and let's say you had a printer, okay, that you wanted to connect up to your computer to print your documents out of WordStar. All right. Drivers, you had to create a printer driver for every program that was written. So the application developer was responsible for creating a driver to drive whatever printers he wanted to support. So think about back in the 80s when printers started to proliferate and you started to have laser printers. So let's say you had 100 different printers out there with 20 different manufacturers. Okay, if one of your customers had a certain printer, and they wouldn't buy your program unless you supported their printer, right?
Right.
So what do you do? So you want to sell your program to as many customers as you can, but now you're stuck with having to handle all the different printers that customers have already bought, right, or are planning on buying.
Mm-hmm.
What a pain in the butt that is for an application developer to create 50 drivers.
Right.
Right.
Pretty much hard. I mean, very difficult to keep up with it,
Well, that's the first thing, is to create the driver, but then it changes. Let's say the printer manufacturer changed something in the way the printer works. Mm-hmm. Now all of a sudden your driver doesn't work with their new printers. It's the same model, but it doesn't work anymore. So that's a big problem. So what Microsoft did is they developed a thing called a common object model, which allows any printer to connect up to any client program, any application. And the way it does that is it sets a standard API or application programmer interface standard for a printer. So basically all printers have these particular features. All printers do these things, okay? It's a list of things. They support these properties. They have different properties for each printer. What paper they support, what kind of fonts they support, what kind of ink it is, if it's a laser or if it's an inkjet. There's certain properties that are common to all printers, and also certain methods that you can do with the printer. Certain things that you can do, like I want to send a character to the print and print it out, or I want to do whatever the printer does. There's a standard set of these functions or methods, as they're called, to do. So what you do is you create this driver. It's like a middleman that stands and it's an interpreter that takes these API, these standard functions from the application program and interprets them into the printer command language, okay? So the printer has this proprietary command language that it talks, and the driver turns these generic commands or these common commands for all printers into the specific proprietary command to talk to the printer. And so that allows application developers to say, oh, I just need to download your COM driver for the printer, and the manufacturer is responsible for creating the COM driver. Okay, which makes sense because he knows all about his printer and he knows how it works. So he can say, I'm going to map my proprietary language into the language that all printers speak. Okay, it's like an interpreter. And that's how you that's how you free up the application developers to say, oh yeah, I support all these printers.
Yeah.
Because I support the COM object model for devices. That's exactly what ASCOM is for astronomy equipment. Okay, before ASCOM, before the turn of the century, basically, every application developer had to create a driver for every stinking piece of equipment that's out there for astronomy equipment. Cameras, mounts, filter wheels, all kinds of stuff. They had to, and you'll see them still today in some applications. You'll see pull downs that show which device are you going, and they're called native drivers, is what they're called. Okay, you'll see that term, native driver. But pretty much all manufacturers of equipment deliver ASCOM drivers now. Just as we do with the PMC8 system, we deliver an ASCOM driver that allows any client program, any astronomy program that can talk to a mount, talk to the PMC8. So that's basically the purpose of the ASCOM initiative, is to provide these architecture for people to write drivers to talk to astronomy equipment. And here's a pretty good diagram that kind of demonstrates what I was just talking about. This monolithic structure on the left, this is the way it used to be. Astronomy program with built-in device control.
Yep. So that would have been like very early, at least in the history of GOTO amateur telescopes. That would have been the Vixen's, the Vixen device, which was the first one that was out in the 1980s, mid 1980s. They came out with this. And also like Celestron's CompuStar system, which was developed, but was a program they actually didn't own at the time. Mead Instruments ends up buying the program, and that's what develops into the LX200. Then it became extensible. Excuse me.
Extensible, right?
Yeah. So explain what extensible is.
Extensible is kind of halfway between that and what we have today. Extensible was a vendor. A vendor would create these plug-in layers, so that so you could use different programs with the same plugin layer. It was hard coded into the application. It wasn't open source or anything. But basically, several vendors' programs can share the device control for that device. So it was internal, that type of thing for the vendor.
Mm-hmm.
And then we got to the point where we were at the ASCOM level.
Now, Mead did that extensible, the possibility for it to be extensible because they came up with their command language set. And we then released that set at Mead to really just very select people. I mean, they didn't make it easily available to everyone until we decided to publish it. But it started out with just a few software makers could control it, and the first one of those was Software Bisque.
Oh yeah, right.
Very early versions of the Sky.
Yep. And then, as I described, this is what we have today on the right, ASCOM, where it's a vendor-independent astronomy program in any language. You can, and ASCOM was developed on the Windows platform, and like I said, that's really its first implementation over the last 15 years has been through the Windows. But 2 years ago, ASCOM has created an open source or an open platform development to allow ASCOM to operate over a network system over the internet, and it can work with any hardware platform. And it's Mac OS, Linux. It's called Alpaca. I'm not going to get into Alpaca, but that's the cross-platform version of ASCOM is what it is, and provides tools to communicate over the network around the world with devices. The next thing I want to show you, are there any questions about any of that on the forum, on the chat?
Jerry and Scott, it might just be me, but the video is fuzzy, so I can't read the screen. That's so. Is anybody else having a tough time? Maybe you can let me know.
I can enlarge the text a little bit more.
Let's read some comments at least. I think there's a question for you. Oh, this goes back to your book. Someone's asking if they should get the scientific imaging book before they get your remote observatory book.
That's kind of the way I had written the books. Is the first part is about your equipment and how to integrate it and use it, scientific astrophotography book, and the second book, the remote observatories for amateur astronomers, builds on that and takes what you've built into a standalone platform, which I call your AIS, your astronomical imaging system, and you take your astronomical imaging system and you turn it into a remote observatory. And that's what the first part of the second book gets into, is how to take the AIS and create a remote observatory out of it. The second book also talks about the commercial services that are available for you to use, the remote observatories that are commercially available. And the last part of the book talks about what different projects and what observing programs you can do with the remote observatories. So, so the second book, Remote Observatories for Amateur Astronomers, is built to be built on top of the scientific astrophotography book. So, yes. So,
okay.
The next thing I want to talk about is I want to get into details. Let me see. Does this window show up? Did I
Yeah,
share my?
actually, it was just one guy. Everybody's seeing your screen. They say crystal clear. So
Okay, good.
uh, I think they're recommending he changes his monitor settings.
Let me. I'm going to stop and reshare.
Bergman Scooter says no problem here, but I'm watching on a 65-inch television.
Yeah, right. Exactly. I'm gonna share again and share the. This is part of the developer help. Does that look big? Let me see what it looks like on the screen. I'm watching it on my TV too, back behind me. That's why I keep looking back. I'm looking at the TV to see what the screen looks like.
Yeah, it
Oh,
looks sharp
okay.
to me too.
That looks pretty good. Okay.
We appreciate anybody that tells us that our sound's not good or our video's not good. You know, we want to try to get this across as well as we can.
So the last thing I wanted to talk about with ASCOM was just give you an idea of what kind of things are we're talking about methods and properties with the ASCOM driver, and I developed the ASCOM driver for the PMC8, so it has all of these different things in it, and I'm just going to talk about a few of them just to give you a feel for how many things there are involved with a mount. You know, people don't realize all the different controls that you have with a mount and what different things a mount does. There's a lot of parameters involved to configure the mount and also to provide information to your client application. So the ASCOM client, that's what we call the application that you use, like Cart to Seal or Maxim DL, what is some of the APT, astrophotography tool. You know, all these client programs that talk to mounts use the ASCOM API, and these applications like to have this information about the mount and about your location and other things that are involved with your system. So you can see there's things like altitude, azimuth. You know, that's a variable you can query about the mount where it's pointing at. Now you can, there's different things like this can park, can pulse guide, can set declination rate. These are like capabilities that the mount allows you to do. You can set a park position, you can set the pier side. You know, there's a lot of these types of things. Well, the mount can slew, which is kind of you would think that pretty much all mounts could slew, but that's a feature, you know.
Not true.
Basically, it's a whole list of different things that the mount is capable of. That's what these can things are. And then you have real-time values that get updated on the fly, like declination. And up here was azimuth value. There's
so the question is, it's come as, what features does the PMC8 ASCOM pass through for Sky Safari? Is it all of these features?
Sky Safari is a special, you know. So just in general for ASCOM applications or ASCOM clients, the PMC8 is programmed to provide all this data. It's completely compliant with every single API. This is the API. This is the properties that the API exposes to the client program. Okay. So these are the information that PMC8 provides to the client program. All these things. So you can see it's quite a bit of stuff that I had to program and figure out how to provide it.
How about the point and track modes that are in the Explore Stars app? Is that?
So Explore Stars application is not an ASCOM application. Explore Stars is kind of like the legacy application that we had back in the day, where you have the actual application, which includes the user interface. It includes the calculations that are done behind the scenes of the user interface, but it also has built into Explore Stars all the communications to the PMC8, which uses the PMC8's native command language, like I talked about before, when you had these old applications that talked to printers
Mm-hmm.
and you had to talk directly to the controller. That's exactly what the ExploreStars application does. It uses the command language for the PMC8 to drive the mount directly, and that way it's a monolithic program like we were talking about before.
Yeah.
Now we could turn the ExploreStars into a ASCOM compliant application, which I don't want to give anything away, but that's probably going to happen at some point. It won't be. It's not going to be the same. It's not going to be the same
I don't want to say
program.
we're doing that, but yeah, we're doing that.
Yeah, but we're going to be doing that, right? Exactly. So that's something to look forward to. But it's going to be in a whole different. There's a whole different reason. There'll still be people that want to use ExploreStars on a tablet like we have.
Sure.
And that won't change. But we're going to be adding. We're probably going to have a new version of all of our stuff out in the next few years that everybody will be able to use.
Yeah, we're not going to stop developing on it.
No, right now we're in the middle of a development cycle that I try to. I'm really busy working on every day and trying to get stuff done. So we'll be releasing some stuff this year that everybody will be happy with, I think.
I think so too.
And I've already mentioned the work that we're doing on the firmware.
Yeah.
And I'm actually updating the ASCOM driver with that new firmware also to support it. So these are kind of the properties. These are like characteristics of the mount. That's what you can think of. Okay. And then you have methods. Methods are functions. They're basically things to make the mount do things. Okay. And also to, for example, let's see, a good one. Let's do this one. Slew to target. Okay. Slew to target method. All right. That's a function that you call to slew to a target. And of course, it looks a little sparse right now. All it says is slew to target. So there's no parameter there, right? You just call slew to target. So part of the API defines, okay, what's the target? Well, you have to go back and look at, let's see here. There's a target parameters. See here, target declination property. And you have target right ascension.
Yeah.
So you've got two methods. You can set the target right ascension. Okay. You can set it, which means you assign the value of the target for right ascension, and you also do it for the declination. And once you set those, you can also get them if you want to see what the current target is. Okay, you can get that. That's a get method and a set method for the target. And then, so what happens is you set these targets, right ascension and declination, and then after you do that, let's see here. After you do that, you do slew to target.
Has a number of questions here. I should probably interrupt here and just catch up. One question is which equipment do I choose in Sky Safari to maximize the PMC8 feature access? I think that would just be one selection.
Well, I want to talk about Sky Safari. Sky Safari doesn't support PMC8 system. Remember?
Well, isn't it true that it just doesn't have a park feature? Is that right?
No, remember Sky Safari is...
Oh, that's right.
It's Stellarium.
I'm thinking of another program.
Yeah, you're thinking
Right.
of
Sky
Cart to
Safari
Seal.
does not. That's right.
No, so Sky Safari is a monolithic program like we talked about, where the original developer created drivers to talk to all the different mount systems
That's right.
directly. And we I don't want to get into it too much, but we tried to get into Sky Safari, but we could not get the PMC8 language to be put into the Sky Safari program.
At least not yet. So maybe in the
Right.
future.
But if people ask for it, if you use Sky Safari and you want to use it with your PMC8, please ask the people there at the simulation curriculum.
They already were given the all the SDK and
the command language
stuff that they need. So
now there are workarounds. I know that the people that created Sequence Generator Pro created this little tool. Can't remember what the name of it is, but what it does, it allows a Sky Safari to talk to a Windows computer that runs ASCOM, which can control the PMC8. It'll allow you to use Sky Safari to control an ASCOM connected PMC8 system through the Windows box. So it's a little program that runs on the Windows box that will connect to the Sky Safari.
That's what Eduardo Simone is pointing out. He says it does work with PMC, but there's an app.
Yeah. So unfortunately, that Sky Safari doesn't support PMC8 yet, but hopefully in the future it might happen.
Yeah. Right. And those guys at Simulation Curriculum, they're really talented people. Really admire their program. I use Sky Safari on my phone too. I love the program, but might love it more if it ran my telescope.
Yeah, right.
But I do use it, folks. I do.
Yeah. So this gives you an idea of what the ASCOM API is and what it does. When you download the ASCOM driver for the PMC8, it includes a checkbox when you install it to install the source code for the driver. And if you're into programming, you can take a look at that and see how I implement each of these API functions and properties. And so I guess that's about all. If there are any more questions about ASCOM, and
let's see. There was a number of different comments and questions. Another question was, could they jump back and forth between Sky Safari and Explore Stars as far as controlling the telescope? But I think once you're kind of if you ran the app that would connect with ASCOM, I think you would be hardwired into the PMC8, right?
Yeah, so so you're actually, what Sky Safari is controlling is a computer that's running the PMC8 system with the ASCOM driver. So it's an interface to the
new firmware, which will switch back and forth.
Yeah, so that's exactly right. So if you connect to the host computer to the PMC8 it's connected via serial. You can control that with Sky Safari through that little interface program, and move them out. And then also, since we're making the serial and the Wi-Fi available at the same time, you can connect Explore Stars to the Wi-Fi, which is the only way it connects to the PMC8 anyway. You can connect Explore Stars directly to the PMC8, independent of the host computer, and you can drive it there too. So you will be able to do that. Yes.
Eduardo says if you use Indy, such as K-Stars, they ask you if you want Sky Safari to be able to connect. So.
Oh, so if you have Linux or Mac OS with Indy, then apparently they've got a driver already set for Indy. Now that's interesting that they developed an Indy driver, but not an ASCOM driver. Why is that?
I don't know.
Yeah. So.
There's people. I mean, Indy's for the Mac OS system, so
and Linux, right?
And Linux. So apparently, there's enough groundswell of interest to use those platforms to control.
I guess compared to Windows.
Windows is very established, so.
I know it's very large. It's 10 times or 20 times as many users on Windows than there are on Linux.
That's right. Well, guys, I hope that you watch Astronomical League Live 2 tonight at 6 p.m., which is coming up here in just very quick, an hour and change. I know that the Astronomical League has some special prizes they wanted to give away. So, but it'll be good. Caitlin Ahrens, Dr. Caitlin Ahrens is one of the keynote speakers, along with David Levy, who's going to be there. And Caitlin's from the NASA Goddard Space Flight Center. So it'll be interesting. She's really a great speaker. And a very personable person. She studied at University of Arkansas here in Fayetteville. So I got a chance to meet her and know her a little bit, and very nice person. So I think you'll enjoy tonight's talks and goings-ons with the Astronomical League. Is there anything else you'd like to add there, Jerry?
I just want to say hi to my son, Josh. I don't know if he's watched before. It's the first time you mentioned his name on the program, so I don't know if he's watched before or not, but it's great to see that he's on here. I don't know if he had. I know he said hello earlier.
Watch too, so it's kind of fun.
Yeah.
Knowing that they're watching out there. So very cool. All right. Well, thank you very much. Thanks to all the audience, and Jerry, thank you very much for taking time out today. And
sure.
I know that you were hot and heavy into the programming today, as you've been almost every day. So
yeah, I'm trying to get this firmware done. Wes McDonald and I have been working on the firmware changes. It's a very substantial amount of changes. It's going to be version 2.0, basically. It's brand new PMC8 in some ways. And it's going to be able to be loaded on the legacy equipment that people have already bought. So that's another great thing. It's like getting a brand new PMC8 for free.
Right. That's right. And it will probably always be like that. So
as much as we can.
Yeah. Yeah. We built the hardware to last for a very long time. So, it's something that should be certainly outlast your iPhone electronics.
Yeah, right.
Sorry,
That's
Apple.
right. That's right.
I use an iPhone, by the way, too.
Yeah.
So, all right. Cameron Gillis, I'll try to pop in and out. Sounds like fun. Thank you so much, Scott and Jerry, for your dedication and enthusiasm. Cameron, thank you very much. And if there's anything special that we need help any of you with, please let us know. We'll be happy to get you as far along as we can. Okay? So that's it. And don't forget about tonight. I'll see you in about an hour or so. Take care.